Ladies and gentlemen, it is 4 p.m. in the beautiful city of Noordwijk, the Netherlands. Let's have a company visit to one innovative company in Epic. Today is another special day for Epic. Join me on a virtual tour of another brilliant photonics company whose founders have been major drivers in the development of MEMS mirrors for about 20 years. Augmented are masters in high volume, low power consumption, and small form factor, 3 key ingredients for success. Their novel MEMS mirror scanning solution has been integrated by many Epic members in the fields of robotics, automotive, aerospace, augmented reality, face ID recognition, and industrial manufacturing. We are crossing now live to the headquarters of Augmented in Itzehoe, near Hamburg in North Germany. We are crossing now live, and we are going to the north part of the beautiful country of Germany. We're going to Itzehoe, and I would like to say hello to my hosts today. Hello, Augmented.
Hello, everybody, and welcome to the virtual company tour here at Augmented. My name is Thomas von Wantoch. Next to me, this is Ulrich Hoffmann. We together have founded Augmented, and we are very happy to present our company to you today.
It is a great day because I used to travel 200 days a year, and it used to be a fantastic life. And now we have a certain situation we have to cope with, so we do everything from the comfort of our own office. And having the chance to visit Itzehoe, for those of you who are heavy metal fans, this is a few walking steps away from Wacken. So it is great to be here, it is great to talk to you, and it is great to find out a bit more about Augmented. So let's get the thing rolling, let's walk inside Augmented.
Maybe a few words. We are here located in Itzehoe, as you said, and this is the Innovation Center. And next to me, there's Ralf Thierecke, who is head of the Innovation Center and can give a short introduction.
Yeah, hi, I'm Ralf from the IZ. IZ is an innovation center. Maybe you are familiar with that. So what we are doing is supporting high-tech startups every day. This is our business, and our support is on the one hand infrastructure. So we have office space, we have labs, and we have a lot of other things like conference rooms and so on. In addition, there are services from postal services to whatever you can think about, and the most important of everything is our support in terms of networks. So I believe in networks for startups. This is one of the really key infrastructure things for companies to grow. Yeah, so the IZ is a perfect place to be for startups, and it's a good location here. So we are in the north of the metropolitan region of Hamburg. Hamburg. And okay, you mentioned already Wacken. This is fantastic, and with that in mind, you can see how our innovation park, which surrounds us, grows. And most important for us is, on the one hand, microtechnology, microelectronics, and things like that. We also have a strong reputation in renewable energies and battery systems, so the modern high-end lithium things.
You said 14 companies in the ISET right now. What is the process for any startup in the area of Hamburg or in the area of the world to set up base in ISET?
So the most important thing is that you have really good support. On the other hand, I think next step is growing of companies, and so we have space to settle.
One of the things that all the companies that you have mentioned in common is that they target different markets when the volume is interesting. And on that, Europe always had a challenge. Going to volume production has been always a problem for the European ecosystem. How does ISET support the upscaling of these technologies?
So the most important thing is you need people and employees equipped with the knowledge to do it, and you need the space where you can place your company, and both is given here.
So I would like to say congratulations on this, and also congratulations on having Augmented as one of your 14 companies. I'm not going to hide this. I'm a huge, huge fan of the technology we are about to see. Thank you very much for having us here, and thank you for having this e-virtual coffee with me. Thank you very much.
Yeah.
Let's
You're
go
welcome.
inside.
So Thomas, let's go in and let's find out a bit more about Augmented. I'm so excited. And when you enter the company, the first thing you do is you take off your coat. I don't have to right now. And then we are walking and I love the design. I love the way that you guys look together. Let's talk a little bit about the company, where we work. Just give me a couple of teasers. What is Augmented and what are we going to see today?
Yeah, maybe we should start with our little background and history of Augmented, because we were for quite a long time working at Fraunhofer before we founded Augmented. So the whole story started in 1994 when we began developing of MEMS mirrors and MEMS scanning solutions at Fraunhofer ISIT, originally in Berlin, later moved to Itzehoe here. And yes, and during those 25 years, technology was improved step by step. The people working on that topic became more and more. And finally, we understood that in order to get to real products, it's necessary to leave Fraunhofer. Because within the tight boundary conditions of Fraunhofer, you cannot launch any products and successfully exploit the technology. It's necessary to make this step, to exit Fraunhofer and spring into the cold water and jump into the cold water and start something new. That's what we actually did, and maybe you continue, Thomas.
Yeah, the first thing that when I look at the logo, which is beautiful by the way, is that I see glasses, and then I see an O and a Q. Is that correct? What did inspire you for this really nice logo?
Yeah, so actually the idea was Ulrich's idea. So you all know the name Augmented, so which combines a display and sensing technology, and we just replaced the first letters by O and Q. The O is standing for optical, so we are doing optical devices, and the Q stands for our high quality resonance scanners. So that's the name Augmented, and the OQ is fits very well to a nicely logo. That was the idea behind it.
From the very beginning, you identified Augmented as an optics, as a part of the optics community, even though your MEM mirrors could have application in many other different technology sectors. What was that? Why did you think, let's push for the optical systems scanning instrumentation?
Yeah, we had a very tight cooperation with a very famous consumer company some years ago, and during the last years, I should say. And within that technology development or MEMS mirror development, we had activities going on in the augmented reality development section. And so we were deeply involved into the topic, and this is mainly optically related. And so, of course, there are other applications besides consumer applications. You could also use laser scanning technology for not only for automotive, but also for laser material processing. And so there's quite a wide range of different applications that MEMS mirror technology can support.
It is a huge market. Today we had the 3D imaging, we had the AR/VR market, and also of course the 5G, which is something that is going to demand a huge push from the current photonics technology. Even we are going to have, and I already have phone with 5G, we are a long way to implement the entire supply chain necessary to actually make this manufacturable the scale that the industry demands. And Augmented is one of the companies in this sector. How is Augmented going to support the 5G?
Yeah, so I mean, with our systems and our the applications that we aim, all this data that will then be transferred by 5G is generated, and it has to be then transported to the cloud, then computed, and then transported back, for example, to the displays that we are developing in form of AR smart glasses. So for us, at least, it's very important that the 5G is deployed very fastly, so that it can improve the applications that we are working on.
Yeah, maybe we should add, without 5G, we would not be successful in developing solutions for the automotive LiDAR market, where autonomous driving is a hot topic. So autonomous driving will definitely require 5G, and so there's the link, and so everything is like a complementary puzzle, and so we contribute our laser scanning solutions, and the laser scanning solutions produce a lot of data every second, and without this high bandwidth data transfer of 5G, such solutions could not be realized.
You mentioned now one of the key things that happened when Augmented joined Epic. All the companies manufacturing LiDAR wanted to talk to you, and actually you did business with a couple. So I would like to also congratulate the Epic members who did business with you after your first entry in the Epic network. How important is LiDAR for you, and what is the present and your preferred future for the LiDAR industry and the scanning systems of Augmented?
Yeah, we have from time to time a little sequence in the background display. Maybe you noticed already, and so part of our solutions are presented on its slides, on those slides, and the little video sequences. We developed something very special where we have currently a unique solution, I should say. We can offer to the LiDAR technology market very wide-angle field of view laser scanning solution, which becomes of interest, for example, for blind spot detection. Where you will be aware that most sensor companies for the automotive LiDAR market currently have a focus for large range of measuring objects at far distance. But there's only little activity ongoing for the side LiDAR market. So I mean those parts of the car, those parts of the car that are to the left and right side of the car. So what we are focusing on is development of a Mem Scanner device and a laser scanning solution that allows to implement a LiDAR system small enough into the side mirrors of the car to detect the full range of 180 degrees field of view, to discriminate pedestrians, cyclists, and so on, and to make the traffic more safe by those sensor systems. And currently there's no sufficiently reliable solution available for this wide field of view detection. Most sensor solutions have either smaller field of view or they have very poor resolution, and that's where we come into the picture and want to offer something which is providing high resolution but still maintaining the large field of view. So this is
yeah, you have something there I really want to see, because I have a lot of things on the table. Just show us things that you're working on.
Okay. Thomas.
Yeah, so here you see an exemplary Mem Scanner. So it's not only providing this 180-degree scanning angle, it's still very tiny and very compact. So that's a key for later mass production and cost efficiency. So you see that we as well have a special solution for the housing of this kind of device. So you see a kind of bubble. So we call it bubble MEMS. And this protects the scanner from any external contamination, stuff like that, environmental changes. And additionally, by that package, we can operate the scanner in vacuum, and that means that it does not have any kind of damping inside at resonance. So it's a very low power product, and everything is produced on wafer scale. So what we see here an exemplary glass wafer. So all these devices are already sealed and packaged on wafer level, on 8-inch wafer level. So that's one main point for later volume production.
This is really the unique selling point. You managed to have a very high-end, high-tech scanning solution, and you managed, and this is what I am in love with you managed to do it at wafer level, and this is where I think the whole ecosystem is looking forward to welcoming you. Do you want at some point show us maybe how this works? Maybe show us some demonstration?
Yes, we can go on to the colleagues and have a look and look for 3 different applications. One is focusing on the LiDAR topic, the second one is on augmented reality, and the third one is the topic of 3D sensing, or for example, mobile phones with 3D cameras or tablets with 3D cameras. But we start with the 180 degrees field of view LiDAR demonstrator, and I hand over to Fabian, my colleague, and he will explain in more detail what you can see here.
Hello, good afternoon. Thank you very much for this. We are super excited. I have many people in the room and also in YouTube wanting to see this demonstration. So please go ahead.
Yeah, hi, I'm Fabian and I'm MEMS design. I'm working MEMS design here at Augmented. That means that I lay out our mirrors so they meet the desired physical requirements. This is an example of one of our unique MEMS scanners or MEMS mirrors. It is unique in that it can scan an optical field of view of 180 degrees. To show this, we put one of our mirrors inside this little demonstrator here. You can see the mirror is sitting right here, and behind this red box there's the electronics. For this demonstrator we placed this laser pointer here, which is pointed at the mirror, and the mirror is scanning the light onto this screen here, as you can see. Now our scanners are driven in closed loop control. That means that we always know in which direction our mirror is looking, and that allows us to exactly control the scan angle of our mirrors. In this moment, the scanner is set to a scan angle of 60 degrees, but I can just change the value here to, for example, 140 degrees, and the scanner will instantly widen its angle to 140 degrees.
Wow.
Yeah, so one example application for this scanner would be LiDAR. To prove this, we set up this little creation here.
Oh, this is going to be cool. I cannot wait for this. This is a robot. Oh, right. Okay, there we go.
It's not moving, so the only moving part is our scanner here. The scanner is actually placed here, so it's quite small in comparison to the other bulky stuff. We added another component here, which is an infrared laser down here and a spot detector here. And this combination allows us to scan our surrounding by scanning a vertical laser line horizontally, and then measuring the time the light needs to travel this distance to an object and back to our detector. Here in the image you can see a little environment we created to test this setup. For that we placed a paper figure here and a bicycle in our cellar room. And yeah, down here you can see the point cloud that is created with our scanner. In this setup we reached a field of view of 160 degrees, which is actually, the limitation is through our detector optics and not our scanner. And yeah, this is a great result for such a first setup for our proof of concept of our mirror for LiDAR application.
What is the typical scanning speed that you're using?
Yeah, the mirror is scanning at 1.5 kilohertz. And with this setup, we are able to reach about 20 frames per second image.
20 frames per second.
Yeah.
Okay. No, but what is the demand that you normally get in the LiDAR segment that we normally get from the customers in terms of scanning speed? What is really is there a challenge there when it comes to scanning speed?
Yeah, so there is a challenge, but the typical values we hear from customers is about 10 hertz, I think, right?
That's the minimum at least.
Yeah, maybe we should say for those customers who need higher frame rates, we just can spend some more resolution or offer more resolution, or less resolution. So higher frame rate can be combined with lower lateral resolution, then you can increase the frame rate. So it's not the limit. So we can have 20 hertz frame rate, or it can also be higher than 20 hertz. Depending on the resolution that we want to achieve, the lateral resolution. So if we decrease the resolution, then we can increase the frame rate. So this is the relation. So it's always a trade-off, but this is already quite high frame rate and high resolution sensing.
I was very happy and also impressed to see that also with a software control you managed to tune the field of view. You went to 140 degrees. What is also a typical field of view that customers in the LiDAR segment are demanding?
Yeah, so, well, as already suggested, so we are working here on a wide field LiDAR. So we think that it would be very good to have in the car at the surroundings in the rear and in the sides a LiDAR that is able to provide up to 180. So that means less systems are needed for a full 3D view around the car. So we are proposing with our solution a 180-degree field of view.
When it comes to the LiDAR, so on one hand, we have the automotive, which is going to be a booming market. It's going to be very interesting. There's a bit of hype there, but there's a huge market opportunity for the LiDAR in the industry automation segment. And that is growing steadily. And that's a huge market for the high-end optic systems community. Do you see different set of specifications coming from the LiDAR clients in industry automation than the ones coming from automotive?
Yeah, so I mean, the biggest difference is that in industrial applications, you do not need all this automotive grade. So the AEC Q100 certification is not needed. So that makes, let's say, the system setup much more easier. The volumes are lower, but from the specifications and requirements, I think there are some different applications, but it's not that different from what we can provide here and I use in the autonomous space as well. So I think that industrial space, there are as well applications where it would be good just to have one or two small tiny sensors for having a full 3D 360-degree field of view. So and that's what we can provide as well with the solution. And for us, it's easier to assess this because it's not automotive grade. So, but we are as well focusing on automotive market because we have the only solution that due to this vacuum packaging can provide automotive grade Mem scanning.
Having your process automotively qualified, did it demand some effort from your side or from your customers, suppliers?
Yeah, so at least the full supply chain has to be automotive qualified. Up to now, we have not done this completely for the full supply chain, but we have already shown with customers that our MEMS mirrors are capable of achieving all these requirements that are required. So all these tests have already been done with special designs of our scanners, yes.
And you know what, Thomas, the last time we met, you told me that you do something on augmented reality, which is very cool. So I heard you have another demo on AR/VR.
Yes,
You should know something about me. I love photonics. I also love metal music, and I go to Wacken, and I also love gaming. So anything that you show on AR/VR makes me super excited. Hello.
Yeah, hello. This is our colleague Oleg, and he can give a little introduction to the augmented reality display activity that's going on at Augmented.
Hi, Oleg. Thank you very much for this. I'm particularly excited about this. Go ahead.
Yeah, you're welcome. Yeah, thank you. So first of all, here I would like to show you our small and very handsome. Switch on the light, please. Very handsome and very tiny Mem Scanner, which is used for applications in AR and VR, also for pico projection. And yeah, this is so. Please make a look here to this system. This is a test system which I'm currently working on, and yeah, I set it into the operation, and it's now right now it's running in real time. And the MEMS is controlled by our electronics here, and projecting video what is coming from the computer directly. So if you look here, you can see this small and beautiful Mem Scanner, which is resonant oscillating in 2 axes, and the laser fire the image, the pixel information, and it gets reflected by this mirror and goes to our MEMS device, where it is deflected into both axes, X and Y. It operates synchronously, means that the pixel information is sent to the laser according to the MEMS position. And in this way, you can project a whole image on the projection wall here, or the projection surface. Any questions so far?
I'm just impressed. It's very difficult for me to not have words to say, but I'm just extremely impressed. So this is, of course, there's a huge market coming, and we already heard the announcement of the eyeglass last year from Google, the investment of Shot on a smart glass, the investment of Bosch Sensor Tech on a smart glass. This is something that is coming. So what is your preferred future? How do you see Augmented's AR, VR scanning solutions evolving in the market?
Yeah, maybe we should first start again with some more explanation, because
I would also wanted to show you another.
Oh no, please go ahead. So you're gonna show me glasses.
Demos, just you can get a better understanding what we're able to do with this scanners devices. So look here. So the main idea is, because the Mem Scanner is so small, it can be easily integrated into a glass frame here.
Into the temples,
yeah. And so in this way, the whole form factor of the light engine can be achieved, can be kept very small. So means that using our MEMS technology, you can easily integrate it, and you can actually enable all this augmented reality applications for the customer market. So for all day wearable smart glasses, for example.
Maybe we should mention some differentiation between augmented MEMS mirrors and MEMS mirrors from other suppliers or competitors. Most other competitors have solutions that are based on 2 single-axis chips, and we use only a very small form factor 2-axis laser scanning chip. And that offers us an advantage with respect to size, manufacturing costs, so it can be very low cost mass production. And what is also very important for this kind of MEMS mirror is the power consumption that we can offer. It's extremely low. Thomas mentioned already some minutes ago that our MEMS mirror devices are hermetically sealed in a vacuum environment. And that means that most of the energy can be conserved in the resonating system without any losses. And that offers low power driving of such MEMS mirror solutions. And this low power consumption is of particular importance for all kinds of mobile applications, and particularly also for these augmented reality displays. So the lower the power consumption of the MEMS scanning device, the longer is the runtime of the operating AR glasses. And so that's something where we see a good future for Augmented. However, we need to be aware that Augmented is a young startup and does not offer or have history such as the big companies, Bosch, Infineon, and so on. We need to demonstrate that our technology is superior. Competition is a race. We want to convince customers that this is the optimum solution to a small form factor, fashionable AR glasses, smart glasses.
You went for something that is small, that is affordable, cost effective. In this case, actually very cost effective, and also that requires low power consumption. So what you need are system integrators in environments that demand these three. And then of course you talk about the consumer electronics. I saw the mounted of the glass. Is it difficult for a startup to outreach these kind of companies?
No, actually it's not. Based on the long history we had at Fraunhofer, more than 20 years, we were well known already among those big companies, and so it was not necessary that we do a lot of advertising. We were contacted by these big companies by themselves, so it was just a reverse way. We did not have to contact them. It was sufficient that they knew how to contact us.
I also would like to know that we have something else for us, right? You're going to show us a 3D camera system. Am I right?
Yes.
Let's go. Let's see it. I'm super excited. So far, I'm actually getting lots of WhatsApps. I think checking here. Everybody's actually congratulating for this demonstration so far. Okay, 3D cameras. Hello, I'm Jose from Epic. How are you doing?
Let me introduce you, Lars and Marcel, our colleagues that are working on 3D camera demonstrators. So here we are using the same MEMS mirrors, the same electronics to just set up another application demonstrator here showing a 3D camera that is capable to provide millions of 3D data points a second. So please go ahead.
Hi, at first. We have a little video for you prepared to show the data requirement of the 3D camera. If it will work. No, it won't work. Okay. There you should see.
First, what are we seeing? Is that a gargoyle? It looks like a
it's
dragon.
a little dragon.
Yeah, cool.
This little dragon here in front of you. And this is our primary 3D scanning object at the moment. So there are a lot of details we want to show. And on the right side, you can see a false color picture of the distances. And on the left side, you see the amplitude image. So we can, as Thomas already mentioned, detect up to 250 million distance and amplitude values per second. And this is with this current setup. In the future, we want to miniaturize it a lot, but at the moment, this will work as a nice camera.
We live definitely in the segment of 3D camera systems. The new iPhone 12 has LiDAR on it. The people who are developing hyperspectral imaging, they require ultra fast 3D cameras. Everybody is going into this direction. So what is the preferred future for Augmented on entering this market segment? Are you looking towards also the consumer electronics cameras, or perhaps also in this case you can also target some high-end or other market segments here?
Yeah, so we are targeting both markets. So as Jan said, we can provide a very high data range per second. So with the very fast scanners we have and a single diode laser, and here in this setup in APD, we can provide so many data points. That's interesting for the industrial people, but for the consumers, I think as well. So as we said, in the iPhone, there's the first 3D camera, but this is still limited in the pixel size, the pixel number, and the frame rate. So with our MEM scanning solution, we think that we can drastically improve this 3D cameras, and we are as well aiming at consumer and industrial markets with this kind of cameras as well.
We live in a world in which everything has to be 3D image, from the driver while it's driving to the gamer in front of the TV to the person who goes to the doctor. The market is huge.
Yes, right.
In future, you will pay with your face, and for this, to make this kind of payment process safe, it's necessary to have high-resolution 3D camera systems. And this is one approach to have a scanning laser using our Mem scanners and building a short-range LiDAR camera with very high data rate. And that's the one option to make this 3D sensing a safe way. And this is not only for the consumer market, but also for regular payments and many interfaces that are coming in the near future. And we have to think of all the mixed reality markets as well. You can only do appropriate mixed reality if you do not only have a superior display, but also the necessary 3D sensing capabilities. And that's where we also want to contribute our products in the future.
I was told that you were going to show me the clean room, and I think I forgot my clean room suit. So how do we solve this? Let's go to the clean room.
We switch over to our colleague, Stefan Marauska.
Yes.
All right, we go to the clean room now. Let's see how the technology is made. Hello, this is Jose from Epic.
Hi, Jose, can you hear me?
Loud and clear. I can also see you very, very clearly. What are you going to show us?
Very good. So I'm Stefan Marauska, Head of Operations from Augmented, and I'm at the Fraunhofer location at the moment, roughly 100-meter beeline from the Augmented headquarter. And I'm directly inside the clean room complex and give you now a brief window tour throughout the different compartments which are visible from this side.
Fantastic.
So we, as Augmented, using the Fraunhofer services for development and manufacturing our MEMS devices. This equipment of this clean room is 200 millimeter state-of-the-art for MEMS manufacturing, up to 1 million devices per year on an area of 1,000 square meter.
200 millimeter wafers, 1 million devices. So how many wafers is that? My math
depends on the sample size and the die size itself. So it's between, let's say, 1,000 and 2,000 wafers per year.
Fantastic. And that's just the beginning. So if this technology is fully suitable for upscaling, so any company wants to actually go into higher volumes, we can make it happen. We're just waiting for that. Please continue.
That's true. That's true. We are capable of extending here the capabilities of up to 5 million devices with certain measures, but we are also in contact and exchange with commercial foundries throughout the world to scale even beyond, depending on the customer demands. Going back to the window tour here behind me, you see the lithography area with the light, yellow light, where we bring photosensitive layers onto the wafers for protecting them in subsequent processes, which is an elementary process for wafer manufacturing, and the wafers came several times through this area.
Do you use optical lithography for the manufacturing?
Yes.
Is there any wafer stepper envisioned in the future?
Yes. True. That's what we're using. We're using wafer steppers. We're using classical coaters and developers, which are standard equipment for semiconductor and processing.
If there is a generic process, how many? Just to have an idea, how many steps? How many steps do you have in the clean room for the people to follow?
I would say it's around 70 different steps, ranging from lithography steps up to deposition steps, etching, wet etching, dry etching, cleaning, and so on. So up to 70, including with microscope controls and test measurements.
To be fairly honest with you, I thought you were going to say a lot more than that. Because I was comparing this with the integration of silicon photonics in MEMS, and there is a process for that going for the members, and it's about 150 steps. So this is actually quite optimized. One more thing to be quite amazed with the technology.
That's true. So this process was developed roughly 10 years ago, and it's already quite mature. So it's a polysilicon-based technology out of which we are manufacturing our MEMS devices. And we have these unique wafer bonding processes, which allows us to encapsulate several hundred devices in one process instead of, let's say, die placement and typical assembly processes.
How many people do work in the clean room normally?
It depends. I would say, to give you a rough number, it's 30 to 40 people roughly.
And do you require
from operators and engineers?
The typical class, from what I see behind, is about 10,000, right?
It's ISO 3 to ISO 4, if I remember correct, from the clean room class area. The better ISO class is in the lithography, and in the other compartment it's a little bit less in the requirements with respect to cleanness and dust freeness.
It is great because you manage to have a process that is a MEMS process that also can incorporate optics at wafer level. And that's quite amazing, in only 70 clean room steps. What else are you going to show us? I want to see more windows.
Let's go one step further. We are going now to the wafer bond area, where we do this wafer-to-wafer encapsulating process for hermetically sealing our devices with a vacuum inside. As Thomas mentioned before, this is, for one thing, needed to protect the devices against the environmental impacts like dust or humidity, which is crucial for automotive. But on the other hand, we create a vacuum inside, and by that removing the air damping from the device and have a frictionless movement of the scanner, and reaching therefore high performance in the sense of high scan angles with low power consumptions.
The wafer-to-wafer bonding process, I guess you have a higher class in the clean room, right? This is, from what I see, you're using here, which standard for the clean room? Is it class 100 or is it?
So from the old definition of this US standard, it's clean room class 10. So means 10 particles of 0.5 micrometer in 1 cubic foot. So it's really clean area. As you might see also with the colleagues in the background, they have to wear these protection suits. So it's really dust-free environment to protect any contamination of the device.
You should know, I used to visit 150 companies a year, so I used to go to every clean room and wear the suit, and it was a fantastic experience to see it. And I can't wait to go to Itzehoe, but it's been so fantastic to see it virtually. Is there anything else that you want to show us? Any other window?
Yeah. We have another compartment which we can see from the window area. Let's go a step further. This is the area where we have the precision equipment, the deposit, for example, metals, different kinds of metals. For example, for the mirror plates, where we use aluminum or also gold coating, this is possible. There we have standard sputtering tools or evaporation tools available to have state-of-the-art thin film processing capabilities. But also our actuation material is deposited here. With one of our technologies we use piezoelectric actuation, and also this piezoelectric material is deposited in this area.
Fantastic. The incorporation of piezoelectric materials is, of course, one challenge for any volume production manufacturing, and this is something that you have mastered. For me, when I see the manufacturing, the first thing I think is, in the volume production wafer level, a hermetically sealed product. That's already one thing that is huge. The second thing is, in very high class, we are talking class 10, they managed to do wafer-to-wafer bonding for any kind of material that you need, but they actually have mastered the wafer-to-wafer bonding. And the third part is, of course, here we are talking about having something that is small, low cost, affordable, and with low power consumption in the volume production. Having the whole process optimized and suitable to any company that want to help with the upscaling, that's huge. Thank you very much for this. It's been quite an experience. I hope that soon I can go with you in the clean room.
Yeah, you're well welcome. We hope for that. Thank you very much, and back to you, Jose, on Augmented HQ.
Thank you very much, and back to Thomas. Thomas, it's been such an amazing experience. I saw the window tour, I loved it. And now it is time to relax. I'm gonna have a bit of coffee. I don't know if I need more coffee, I don't know about that, but I always like to drink coffee. I'm gonna drink a bit more coffee. I'm gonna ask you one thing. I'm gonna ask you to answer the epic question. Do you know what the epic question is? The epic question is, you are a company, and the other 620 members want to do business with you. So what can you do for them, and what can they do for you?
Yeah, so what can we do for them? So we are providing our Mem scanning solution for all different applications that we have shown today. So we are open for any kind of corporations in all these spaces, and we would love to get to know more companies from the EPIC community, from lasers and other optical detectors, and so that's what we are looking for. So more partners for integrating all these scanners in different applications.
Yeah, we can add that our company is always open to develop customized solutions. So it's not the case that we have just a few finished designs of MEMS mirrors. We are always open to develop new MEMS mirror devices for new challenges coming from different partners within the EPIC consortium. And so we are open for any kind of cooperation and are interested to hear more on your needs.
Today, normally I travel alone, and I like traveling alone. Normally I travel alone, but today I didn't. Today I came with a group of friends. Today I came with Jakub from Elmo Semiconductor, with Dominic from FineTech, with Michael from FISBA, with Christoph from Fraunhofer FMD, with Sebastian from Huawei, with Frank from NTS Optel, with Benedict and from OQmented. Here we have from Michael with Rod Microtech, and from Dieter from Basak Photonics. I want all of them to have the chance to ask you how you can work together. So the floor and my friends are welcoming your questions. Anybody has a question or something in mind? I think you know me by now. If there are no questions, I ask the questions. My first person I want to have on the floor is Simon from Jabil Optics, from the beautiful capital of optics in Europe, which is Jena. Simon, how are you doing today?
I'm all good. How about yourself?
I'm so happy because, first of all, I love this area of Germany. Second, I am a huge fan of wafer level manufacturing, and I love the demonstration of AR VR. That was out of this world. Simon, how do you think we can do business, Jabil Optics and Augmented?
So first of all, thanks to the Augmented team. Very impressive demonstration and insight. I have to say that we have been in touch with Augmented, so we know each other already from previous discussions. And I think their MEMS-based scanners are really competitive, so to say. And Jabil is all about, let's say, higher integrating those devices into complete AR glasses and complete LiDAR systems. And we know about the quality of Augmented.
Michael, you ever had the chance, Thomas, you ever had the chance, you had to go to visit the showroom of Jabil Optics in Jena. I went there. This is where they manufacture the GoPro camera. So I was amazed by the kind of technologies they can do. And definitely Jabil Optics, a key company in the EPIC network of helping upscaling and helping technologies reaching the consumer and the high volume market. Simon, thank you very much for joining. I'm going to go to the other side of Germany. I'm going to go to Rod Microtech in Stuttgart. Thank you very much for joining today, Michael.
Yeah, hello. First of all, a great show from Augmented. We know us also already from former times or from some visits before. So Rod Microtech is famous for in the industry for wafer test, qualification, component test, and as such, probably we can have a good cooperation there. We are also familiar with automotive qualification of components and so on. So that's definitely something where we can help and support.
Yes, what do you think, Thomas? Is there room for cooperation there?
Yeah, that's actually what we need. So we are aware that we can do everything on ourselves. So especially like automotive qualification. So we are very interested in having partners for this. And yeah, we know Rod Microtech already, so we are in touch with them already.
Yep. You know, Thomas, what is happening right now in Europe? We are living the revolution of wafer level micro optics manufacturing. And it's incredible the kind of things that are being achieved in automotive lighting, the kind of things that are being achieved in consumer electronics. One of the companies in the micro optics market is FISBA. And Michael joined the meeting today from FISBA. Michael, how are you doing?
Fine, how are you doing?
I'm doing great. I hope that you spotted some room for cooperation with my friends in Itzehoe.
Yeah, we know each other pretty well. But I have a question for you. I've seen your automotive LiDAR, the wide angle. Can you tell us what is the maximum distance that you can reach?
Yeah, we already explained that we first started with a proof of concept demonstrator. So that demonstrator was a biaxial system where you use our MEMS mirror for illumination of the scenery and detecting by a second optical path And the target for this kind of demonstrator is to have a range of about 20 meters. That was actually achieved already. There are other applications where people are interested to further extend the range. That can also be done, but probably needs a larger collection optics, receiver optics. Our primary interest is to develop a LiDAR sensor solution which is extremely low cost and extremely compact. So small that it can be easily incorporated and implemented in the side mirrors of the car. Meeting all those requirements and a small form factor, low cost, is probably the key to enabling really next safety level successful introduction of those sensors. We see that the price and the cost of such large long-range sensors is always a challenge to a successful integration or launch of such products in the market. But meeting the low cost expectations of the OEMs is probably the key. And this is something which we have in mind. We want to offer those sensors at low cost and very small form factor. That is not only of interest for the automotive market, it's also of interest for small LiDAR sensors for drones, where you probably need multiple devices on one drone for collision avoidance, for example. So there are many other applications for very small form factor, large field of view, short-range LiDAR systems. And so it's not so our primary focus to meet and to get into competition with all the other big LiDAR manufacturers that already target 250 meters or 300 meters. We can do this large diameter MEMS mirrors as well with partners, but it's not our primary focus. We want to be the first to develop a small form factor, wide field of view, high resolution and low cost sensor solution for side mirrors in the car, for blind spot detection, right turn, safety improvements, and so on. So there are many applications for such small systems.
And,
Okay,
and
thank
the volume production manufacturability, this is the key. This is what we have to explore with Documented. Wasatch Photonics. Dieter, how are you doing?
Good, Jose. Thank you so much. I have a quick question. I was just wondering, you showed the 3D scanner. I come from the Raman spectroscopy side. Do you think that can also be that 2D mirror can be combined with the Raman system where a laser shoots out and the signal comes back in and gets imaged into a spectrometer?
Yes, absolutely. Maybe we should know more details on the acceptable scan speed. Sometimes the different detection concepts require the scanning speed not to be too high, because there's some integration time needed to get to proper signal quality and so on. So I would expect and would not be surprised that you probably need a kind of adaptation of the scanning speed and mirror diameter, while 180 degrees field of view is probably not required. We can already tell you that, yes, definitely we are open to think of such solution and customized developments as well. That's definitely something we can do, but we need to know the proper requirements coming from your optical system, your laser source, and the integration time needed for that signal processing.
One more thing I wanted to talk to you about, because you mentioned a lot of the volume production, 3D scanning, Face ID recognition. There is a company in Epic that is helping many members on this particular market segment, and they are in the Netherlands. So let's make a connection, Germany, the Netherlands today. Frank Ernst from NTS Oftel, how are you doing?
Hi, I'm doing fine, thank you.
After seeing all this, what's on your mind?
Well, first of all, I think the demonstration was very interesting. It was a perfect demonstration. NTS already has contact with Augmented to deliver a scanner, a tester for these scanners.
Yes, we are already in contact with NTS Optel, and
Right,
you will
right.
be an important partner, as the other ones we discussed with before are as well important partners to us. You all understand that we are already well connected within EPIC, and so it's a very nice community, and it's the big advantage of this community that everyone can cooperate with everyone, and NTS Optel is also one of our important partners for demonstrator setups or for measurement equipment. Yeah.
We have a lot of people in the room. I also would like to say that if you have any further questions or comments, now is the time. But when it comes to the integration with backend process, I want to go. The last time I want to go to IMTech. I want to go to Matthias. Matthias, we've been talking a lot about integration of technologies and of backend integration of technologies. When you see a company like Documented that manages to do volume production of something small with low power consumption at wafer level, what do you have in mind?
So what I do have in mind for sure is large volume for automotive industries, but on the other hand, but this is maybe something more where Jabil Optics is in. So we are not a really high volume manufacturer, but what I also think is that this device is very well designed and developed for niche markets. So I'm thinking about medical technologies. I'm thinking about scanning of patients. I'm thinking about scanning of, for example, people who live in nursery homes and something like that. And this is exactly where we can be a door opener for such kind of niche markets. And we can also be, for example, a company who can partner with you in terms of very special developments for low quantity applications, but high quality applications. So I usually call it the prosumer market and not the consumer market.
Okay.
So automotive is more consumer. We are talking about millions or even billions of pieces, and this is exactly where I would be happy if we can continue our communication we already had. And maybe that we can both be a door opener, maybe also in conjunction with Jabil Optics in a kind of collaborative competition, so that we can also be maybe a sub-supplier to this company for later assembly, what we cannot perform.
Very good. Thanks a lot. Maybe I can add a little comment. The whole story of our MEMS mirror started in 1995. With the first project focusing on the development of a tiny 2-axis laser scanning device for endoscopy, for minimal invasive surgery. So this is exactly a niche market where maybe we could cooperate as well. And yeah, very good. Thanks.
The endoscopy market is huge. We are talking about actually going into disposable high-end optical systems, and I obviously see this is really your playground, making something high-end at low cost. Well, cost-effective. I'm going to go back to you for the last time to Itzehoe, and I'm going to ask you, because I'm a dreamer, if we had this company visiting 10 years, in 10 years from now, I will have a bit less hair, but I will be equally excited. What kind of things you think you would tell me differently? Think about your preferred future. Dream away.
Yeah, so 10 years is far away. So yeah, well, I think what we are really trying to set up here at Itzehoe is a company that has really nice MEM scanning products, and we want to bring this into the big consumer and automotive markets. And I think in 10 years, at the latest, we will be successful with that. So then we will have hopefully a few products in the big markets, and have a great company here in northern Germany next to ISIT, our clean room, and with own fabrication sites here as well. So that's our aim as well. Yeah.
So let's do it. Sorry, please go ahead.
Sorry. A short comment to add. We are mainly fabless as Augmented, but there's one part which we want to have our own mass fabrication in our own hands, And this is related to those glass wafers, which we showed in the beginning. This is very unique, and this is the key how to produce those devices or glass wafers. That's the secret we want to keep at Augmented and at our Fraunhofer colleagues. And that is something where we want to set up our own production, high volume production here at ITSO, Schleswig-Holstein, in the northern part of Germany. Whereas the silicon parts can be established as at the foundries. You know all those big names of the large volume foundries. So they can take over the silicon parts, whereas we want to still remain responsible for the glass parts.
This is exactly what I wanted to hear. We want volume production of photonics in Europe, and I want it in Germany. Thank you very much for this. I would like to, first of all, congratulate the cameraman. What an amazing job you have done. I also would like to remind everyone that there was no sponsored content today. I didn't ask for sponsorship. I just love technology. If you want me to visit your company, any company member of Epic, just let me know and I will do it. I will be more than happy of doing that. It was great to go to ITSO and talk to Augmented. If you want to know more about the company, just go to the website and look forward to introduce you to any of the participants today. Not only Augmented, but also any other participant. Up to all the rest, from the beautiful city of Northern Germany, Netherlands, thank you very much for a great afternoon. Thank you very much. Until the next time. Bye-bye.
Thanks. Bye-bye.
Thank you, Jose. Thank you, Epic team.
Yes, thanks a lot.